Good morning. Welcome to day 2 on the campus. And for those of you who were with us yesterday, a special welcome back. We had an amazing day on the campus yesterday, and we have another on tap for today, so let's get started. It is my honor and pleasure to introduce today's keynote speaker, Dr. John Foley. Truth be told, as Executive Director of Project Drawdown, one of the world's leading sources of climate solutions, John probably does not need much of an introduction. Suffice it to say, John is a world-renowned climate and environmental scientist, and we are so fortunate to have him with us today. Please join me in welcoming Dr. John Foley on the stage to give us an update on the Drawdown Roadmap, a science-based strategy for accelerating climate solutions. John?
Thank you. So good morning. How's everybody doing today? Fully caffeinated? Got your bagels, your coffee, everything good? All right. Excellent. Well, thank you for being here today and to hear a little bit more about what Drawdown is doing and how we can use science to better accelerate climate solutions and put them out in the world. Because right now we are very much in a race between two very different futures. One future, of course, is the one we don't want, the one we hear about every day, the one that is increasingly becoming apparent and stepping onto the world stage. A world where we don't take climate change seriously, we don't stop it in time, and we live with more and more calamity, more and more disaster, more and more disruption. We don't want this world. Instead, we want this one. We want a world where we actually stop climate change, and in the process, we end up building a better world. A world that's powered with renewable energy, sustainable agriculture, sustainable industries, and a more equitable, more just future for everyone. But to get there, we're gonna have to do a few things. But I believe we can still win this race. This race for the future is very much in contention right now, and for the first time in a long time, I think we have a real shot at this. But how do we get there? Well, the first thing we have to do, in my opinion, is we really have to cut through all the noise and the confusion we hear right now about how to stop climate change and make sure we take another step back and look at the science of what science is telling us about solutions. How do we do it? How do we pull it off? And whenever I think about saving the world or solving a big problem, I always think about Matt Damon. Don't you? I do. A whole lot of movies have been using Matt Damon to kind of figure out how to solve a big problem. Hollywood spent a lot of money saving this guy from a lot of different situations, right? Well, in the movie The Martian, you remember, his character is stranded on Mars all by himself, and he has to figure out how to survive with nothing but his wits and a little bit of science. And I love how his character talks about this. He says, you just begin, you do the math. You solve one problem, then you solve the next one, and then the next. And probably the best line in the whole movie is, there's only one option. We're gonna have to science the blank out of this, okay? Same thing with climate change. We are gonna have to science the you-know-what out of this. Well, to do this, we have to remember that climate science first identified the whole problem of climate change, but now it can help us guide us towards solutions as well. So why is this necessary? It's necessary because finally we're taking climate change seriously, but kind of everybody and their brother is telling us about their favorite climate solution, the one silver bullet they think is gonna save the world. Just go on Twitter, go on Facebook, just read the paper, and somebody's got a climate solution to sell you. And it might be one of these or a whole bunch of others, as if it's a single solution, the perfect answer to a very complex problem. But no, that's not really how it works. And that's not really what we need to do, because we can be subject to hype, we can be subject to greenwashing, and kind of forget about the substance of what really is out there. So how do we make sure we avoid hype and avoid greenwashing and get to the solutions that really work and the strategies to implement them that have the best chance of actually solving the problem? Well, this is what we need to do to avoid being distracted, falling into delay, and losing this race to the future. How do we turn that around and win? That's where climate science can help us once again. So let's think about that. What solutions actually do work? Well, at Project Drawdown and other places, of course, we've been assessing the efficacy of different climate solutions. For example, these ones in electricity, showing solutions we know work today. Things like enhancing efficiency, producing renewable energy, things like this. We can look at solutions in food, we can look at solutions in transportation, and build an entire library of climate solutions that we know are effective, that they're here today, they work, they can grow to scale, and they're affordable. So these are solutions that are based in evidence, and we should always, always, always look for a good evidence base for climate solutions to make sure that they really work well. So I like solutions that are backed by evidence, not by hype, not by greenwashing. You do too. These ones work. The other thing that's really important about climate solutions, though, is that they work economically. And so we can look at the kind of cost curves of climate solutions and figure out which ones are the most economical. Here's a way of looking at climate solutions by building a cost curve where we compare the cost of climate solutions compared to what we do today with fossil fuels, unsustainable agriculture, polluting industries, and so on. The really good news here is that about 80%, all the solutions below this line, are cheaper than the world we have today, at least in the long run. If we look at these climate solutions and ask how much will they really cost us over the next couple of decades, 80% of those solutions, all the ones below the line, are cheaper than the world we've been building so far. That's great because climate solutions are actually cheap. And cheap solutions are the best solutions because then we can do lots more of them. So I like solutions that are based in evidence and cheap as hell so we can do the things that work and do a lot of them. So let's always make sure we're looking for those. But that's just the what of climate solutions. Kind of what solutions are backed by evidence, which ones are most effective. But now, this is the real trick. We have to move from what to how. How do we implement these? In which order, in what time frames, in what places, what sectors of the economy, in what mix? And this is what I'm going to talk to you about now. But here's the trick. Here's the thing we always, always, always have to remember. The red line is the one we have to move. This is the emissions of greenhouse gases going into the atmosphere every year. Right now, that number, if you include methane and N2O and everything else, is close to 60 billion tons of CO2 equivalent greenhouse gas. And that number historically has been going up over time, just the opposite of what we needed to do. We have to bend that curve and bend it fast, as you know, and drastically cut emissions as quickly as we can, and cut them as close to zero as humanly possible by mid-century. But as we know, it's still unlikely to cut everything in every country, in every economic sector, voluntarily to zero by mid-century, even with all this effort. So that's where the green line will come in. That's carbon removal. Whether we use nature or we use technology, we're hoping to grow carbon removal from essentially zero right now, very, very small numbers, to something that's in the gigaton range by mid-century. That's going to be a huge effort and take a lot of work. But by that point, hopefully we can get to gigaton range and then reach net zero, mostly by cutting emissions and then by growing carbon removal to a scale that really can help. But the real issue here that we often forget is that climate change is a cumulative problem. The temperatures we experience on Earth today aren't from this year's emissions. They're from the emissions of the last century, building up, changing the atmosphere. The work that this has done over decades to warm the atmosphere is just showing up now. There's a long delay in the system because it accumulates impact. That's also true for climate solutions. We always, always, always have to remember that climate solutions are cumulative too, and they depend on time. So if we cut emissions in the next decade, it's going to prevent this much CO2 from going into the atmosphere, that blue area. So early emissions cuts taken now over the next decade can keep that blue area from ever going in the atmosphere, and that's fantastic. But if we cut emissions this decade, it pays off into the future as well, the next decade and the decade after that, accumulating into a very large total impact. Well, we can cut emissions again in the 2040s and again towards 2050s or so and keep cutting, but the longer we wait, the less impact those emissions cuts will have. And that's just the laws of mathematics. So the longer we wait, the less impact climate solutions have. Carbon removal is going to face a bit of an uphill battle because it starts at a very small number and it's going to take a while to accumulate and build up to a total solution that looks something like this. The key here is climate solutions are the area under the curve, not the curve itself. That's why time is so important. Overall, though, what it tells us is when we do the math correctly and we do the area under the curve or the integral, it turns out that cutting emissions is about 96% of the answer of stopping climate change. And a huge part of that, over 76%, is from cutting emissions in the first decade. So climate solutions basically are about cutting emissions and mostly cutting them now. That's what is going to have to do most of the work. Carbon removal is going to be very important too, but its total impact overall is relatively small, about 4%, but we're going to be really glad we have it in the 2040s and 50s. So doing all that math together, what we find is we have something kind of like the time value of carbon. You know, we've always heard that expression about the time value of money, right? That if you want to save for retirement, you don't wait until you're 64 and then save a lot in 1 year. You start early and accumulate money over time. The same thing's true with carbon. We do actions this year and next year and keep on accumulating that impact over time because it's the cumulative impact that matters more than anything else. So with that in mind, we have to make sure that we really think about climate solutions with respect to time. One of the things we have to do a lot more of, I think, is apply what we call emergency brake solutions. Solutions that kick into the atmosphere right now. Things like stopping deforestation, plugging methane leaks, energy efficiency improvements in today's infrastructure, cutting food waste in today's food system. Things that don't have any delays at all, that you do them this year and they affect the atmosphere this year. We need a lot more of these so they can accumulate impact. They pay the biggest dividends because it's like the first dollar you save. Of course, we also need new infrastructure, new energy infrastructure, transportation, food systems, industries, and so on. But infrastructure takes time. It takes time to plan, permit, and build out all this new infrastructure. So we start that today, but knowing that it's going to take a few years, maybe decades in some cases, to build out the infrastructure that we need for the next kind of economy. We also need to invest in nature-based solutions. That's like planting more trees, building up soils, restoring ecosystems. But trees and soils and wetlands take decades to accumulate carbon. So you start those today too, knowing that they're only going to affect the atmosphere into the future. And of course, we always will need new technologies. But new technologies we're innovating today, most of them will fail. And they're supposed to. That's good. That's what we're supposed to happen. But some will be successful. But some will take years, sometimes decades, to get to scale that matters at the gigaton scale. So we invest in those like crazy today too. The trick here is to make sure we have a good balance between emergency brake solutions that bend the curve now, buying time for infrastructure, for nature and technology, because we need all of these to get the job done. But right now I fear we're not doing nearly enough of the emergency brake solutions to make the math actually work. So let's make sure we're balancing these solutions and really deploying the ones that are ready to go, as well as investing in the ones that will come in later. We need all of them, but these ready to go emergency brake solutions are seriously underinvested in right now. Another thing we can do is geographically focus our investments to make sure they have the biggest impact and be very strategic about this. Because using big data and other kinds of things, we can pinpoint where to apply climate solutions to get the maximum impact. This is a data set of every power plant in the world showing how much CO2 it emits for the same unit of energy it produces onto the grid. The red ones are the dirtiest, the green ones are the cleanest. So, and about 70% of the power emissions come from 30% of the power plants in the United States, for example. So you want to take out the red power plants first, replacing those with renewable energy, leave the green ones for last, obviously. So that's a really good idea. Or today we can use satellites to detect methane leaks from outer space, pinpointing areas where strategic interventions are really important. For example, this big leak right there. Let's go there. We know exactly where it is. Let's bring some people and bring some wrenches. We're done. We can solve that. So let's go pinpoint these low-hanging fruits to get these big maximum impacts and make sure we're geographically targeting our efforts to the most important places on Earth. We also have to make sure that we embrace learning curves in our climate solutions. A learning curve is the idea that the more you do something, you should get better at it. And so the more you build a climate solution, it should get better, cheaper, and faster than ever before. But what we see over time, and again and again and again, is that kind of big, centralized, multi-billion-dollar lumpy projects, we call them, tend to be slow. Building like a new nuclear power plant, or a really large centralized carbon capture facility, or a high-speed rail kind of project, or something like that. Things, when they get into billions of dollars, tend to get over budget, over time, delayed, and we don't learn very much because we're doing one at a time, or just a couple at a time. Compare that to very small, modular, very granular kind of climate solutions, where we do them by the millions, like building PVs, or LED lights, or batteries. Things are falling in cost faster than Moore's law ever imagined. So we need to make sure that climate solutions kind of err towards the more granular, because the more we do these things, the more we learn, the faster it gets, the cheaper it gets, the better it gets. Let's learn from the tech industry about how to do things at scale quickly and make sure we have more granular solutions that have better learning curves than lumpy solutions. We should also make sure climate solutions improve human well-being, because we're not just trying to solve for climate change, we're trying to build a better world. One of the best things about climate change is that it helps, when we solve climate change, we solve a lot of other problems at the same time if we do it right. One of the things that's really extraordinary, though, that we have to keep in mind is that fossil fuels, the principal cause of climate change, are also one of the most lethal substances in the world. Just think about this. The air pollution right now from fossil fuels, the particulate matter and smog caused by burning fossil fuels, shortens the lives of about 8 to 9 million people a year. This is the most recent Harvard estimate, shows 8 to 9 million people a year die prematurely from the air quality problems linked to fossil fuels on this planet right now, here today. That's more from tobacco, guns, and warfare combined. So if we clean up fossil fuels for climate change, we also stop 8 to 9 million people a year from dying prematurely due to air quality problems. So that's a huge win-win right now. We also can identify other places where climate solutions on the left, for example, help promote human benefits on the right, especially in some of the most vulnerable places on Earth, where equity and justice issues are still a huge, huge problem. So how do we tackle climate change and improve human well-being at the same time? There are abundant solutions where we can make sure that they're beneficial to humankind. Finally, we have to make sure that what science tells us is we can't do just one thing to stop climate change. We're going to have to do many dozens, if not hundreds, of different solutions at the same time. In other words, we have to build a portfolio of climate solutions. We'll have to invest in lots of little things all at the same time. Well, how do we build the best portfolio? Well, maybe we should align it using science with the actual carbon in the atmosphere, making sure the capital we invest is aligned basically with the problems of carbon in the atmosphere. Well, how do we do that? Well, I already showed you. The science tells us what the math is pretty much. We know we have to cut emissions directly, and we need to cut them in these 6 big sectors: electricity, food, industry, transportation, buildings, and energy processing. We also know that we can double-click on this and find all sorts of subsectors and show you exactly where those emissions are coming from. We can pinpoint them onto a map if you want and show you very accurately where all these things are happening. We also know that we can cut emissions indirectly by investing in people. For example, investing in indigenous communities around the world helps them protect their land and helps people. But that also lowers deforestation rates, which then lowers emissions later on. So investing in people indirectly affects emissions as well. And of course, carbon removal will be necessary to close the final gap to get to net zero. So this is a kind of science-based portfolio of what we need to do. What's astonishing, though, is when the science tells us what we need to do looks like this, we can compare it to what we're actually doing with different forms of capital and see where the interesting alignments or misalignments might be. For example, here's an estimate of where philanthropic dollars have been going to tackle climate change. Basically in the right categories, but maybe a little more alignment here could be helpful. For example, maybe a little more money in industry or in buildings or in energy processing, things like this could be helpful down the road. That would be really good. Venture capital, which has a very different goal. Venture capital is looking to have an exit, to make money, to invest in technologies where we can make a big difference today. So understandably, a lot of it is going into solutions that work right now, where a technology play like electric vehicles, scooters, charging stations, and so on are going to make a big difference. So in this year, it makes a lot of sense that a lot of money went into electric mobility. But maybe in the future, it's going to move to something else as new ideas and new technologies move along. This is a very fluid landscape, and it changes all the time. But overall, let's make sure these different forms of capital are addressing the problems at hand. And then the Biden administration is looking at what it can do with government funding. This might look weird too, but it actually makes a lot of sense too. What we see here is a lot of money going into electricity. In the long run, we'll need to balance this out with other things. But right now, investing in electricity helps unlock the solutions venture capital is investing in. Electric vehicles with a clean grid, clean cars, we got a good combination. Or in buildings with heat pumps, or in industry, and so on. So there never at any one time is going to be a perfect alignment between capital and carbon. It's always going to be fluid. Recognizing different forms of capital will seek out different parts of the capital stack and apply to climate solutions very, very differently. But altogether, they should be guided by what the atmosphere needs and make sure we cover all these bases over time and over different forms of capital. And that's one of the things we need to do much more carefully to make sure that our resources and effort and time are aligned with the science and what we actually need to do to get the job done. So if we look at these kind of different ways science can help inform climate action, I would argue there are kind of 7 key pillars for climate action. We need to make sure that solutions are truly based in evidence, rigorous, third-party, peer-reviewed evidence, not just a hype deck or something that somebody told you on Twitter, but something that actually really works. We want to make sure climate solutions are affordable, ideally cheap, so we can do lots and lots of them, and they can compete in the marketplace with fossil fuels and other things, and win. We need climate solutions that are ready to go right now, so we can buy time for the ones that still take time to develop. We also want to make sure the geographic targeting of climate solutions to put them in the most effective places, hopefully that are granular solutions that have very, very quick learning curves, things that are also beneficial to human well-being and equity and justice, and of course that we align our forms of resources, time and capital and everything else with the carbon in the atmosphere as the ultimate target of what the planet needs us to do. By following these 7 principles as a kind of roadmap, we can make sure that we're taking the most effective actions to stop climate change. Because, it's still a race, very much a race. We still have, though, I would argue, a very, very narrow window of opportunity to still meet the Paris Accords. 1.5 degrees is increasingly looking very dire and difficult, but maybe between 1.5 and 2 degrees. That window is still open, and we have an opportunity to still land there. We can still pull it off, but only if we follow the science, and only if we make every single move and every single dollar matter like never before. We have to stick the landing every single time from now on to have a chance to get through this window. But I think we can do that, and I think with all your help, we can. So to help move us forward, what else is needed? Well, we need to make sure we accelerate our collaboration and work together as well. One of the things I'm really excited to help announce this week is at Project Drawdown, we're launching something called the new Drawdown Labs Capital Accelerator. This is a new program that'll be launching over the next 2 months with these key partners helping us start off and a few others coming down the road. And what it's going to be doing is help philanthropists and investors find the best climate solutions and the best climate strategies by working together. How do we make sure that we have the most strategic alignment between our investing and philanthropy and the science we need to get perfect strategic alignment to make sure we stick the landing every single time? So how do we make sure we get science-based solutions and strategies that have the greatest amount of benefit in the shortest amount of time in the most efficient way possible? If you're interested in learning more about this, I'd encourage you to go to drawdown.org/capital-accelerator, and you can learn more about that and also sign up for kind of an email kind of thing where we can contact you and continue to update you as we roll this out over the next 2 months. It'll go live in November. So a couple final thoughts as we wrap up here today. This is an incredible moment still in human history. Despite the problems of climate change and other issues that are facing us, we still have the opportunity to build an incredible world just within reach of us today. A world that is sustainable and prosperous and equitable and verdant, a world that we couldn't even imagine generations ago. We're the first people in human history to at least have the possibility of reaching a world that is absolutely amazing. And I still think we can get there, but we're gonna have to work very, very hard to do that. But to do this, we must be incredibly bold. We must learn to see the world not as game over, but game on. This moment in particular may be the most important moment in human history for us to step up, be bold, collaborate, and make sure we're guided by the best possible science to get the job done. And I like to say this too, quoting Robert Wilson, the future is still up for grabs, and it belongs to the people who will seize it. So let's make sure that includes all of us in this room, and we work together and solve this problem and make a better world in the process. So thank you for your time this morning, and I look forward to having a really great day with you all later today. Thank you very, very much. Thank you.